Simplified DES is an educational version that demonstrates the inner workings of DES on a simple scale. It uses a 10-bit key with a 8-bit effective key size. It processes 8-bit plain text or ciphertext, whether you're doing encryption or decryption, and it consists of only 2 rounds instead of 16 rounds. This here is the encryption process, this is the key generation process, and this is the decryption process. This figure shows you how the 2 subkeys are generated. Permutation 10 is a function that takes 10 bits and outputs the same 10 bits but in a different order according to the table here. ls1 is a lift circular shift of 1 bit, and p8 is a permutation function which takes 10 bits and outputs 8 bits. ls2 is a lift circular shift of 2 bits, and p8 again is the same permutation that happens in this box, takes 10 bits and output 8 bits. The key generation starts by accepting a 10-bit key, which we will assume that this is the value of the 10-bit key in bits, and it is entered into P10 for processing. P10 rearranges the bits according to the values in this box. So the value of the 3rd bit comes first, and then the value of the 5th bit comes second, like that. We take the value in 3, put it here, and then the value in the 5th bit and put it here, and then the value in the 2nd bit and put it here, and so on. According to this figure, the output of P10 is divided into 2 5-bit parts. These 2 5-bit parts are input to a lift circular shift function that circulates the leftmost bit to the right. So in this here, we will bring that 1 to the right, and we will bring that 1 to the right, like that. The output of the lift circular shift is entered into P8. This is P8. So we rearrange these 10 bits according to the values in here. So notice that P8 takes 10 bits and outputs 8 bits. If we rearrange these bits according to P8, this will be the output. The value that comes out of P8 is K1. K1 is the subkey that is used in the round function number 1. Now let's see how to generate K2. We start by the values that came out of ls1, which are these 2 5-bit values. These are taken here, and ls2 is applied on them. ls2 means that we take these 2 values and move them here, and take these 2 values and move them here, like that. The output of ls2 is entered into P8 again to output 8 bits that will be K2. So we have these bits numbered. We will apply P8 by taking this value, putting it here, and taking this value, putting it here, and so on, like that. This output here is K2. In the next video, we will see how K1 and K2 will get used to encrypt a plain text.